Today in pre-cal we started learning how to verify and simplify trig identities. We have several examples to look at, and a big part of this is just realizing where things come from and how I can get them to relate to one another so that I can simplify them. The first example is that the sine of x minus the cosine squared of x times the sine of x. And that doesn't equal anything, which means it's an expression, not an equation. I want to simplify that. A big part of this will be knowing how things are equal and using the salmon colored paper so that you can simplify. We're using the first three sets of identities today, the Pythagorean, the cofunction, and the even-odd. For here, we notice that they have sine in common, so I'm going to take out a sine x. When I factor that out, I have a 1 right here because sine x times 1 is sine x minus cosine squared x. Okay. I have something squared, which should clue me in that I want to use my Pythagorean identities. For you, it might not be so obvious yet because you don't know those very well, but once you get used to them, you will. So on my Pythagorean identities, the one that relates cosine squared is sine squared u plus cosine squared u equals 1. It's kind of fuzzy, so if you don't have your copy out, you should probably get it out. I'm going to write that over here to the side. And we're going to work with that to make this look more like just this second piece that has the cosine squared. In this piece, I have 1 minus cosine squared. Over here, I have the sine and cosine on the same side. So that I can have the 1 and cosine squared on the same side, I'm going to subtract cosine squared from both sides. And now I have that sine squared x equals 1 minus the cosine squared x. In my problem over here, I have 1 minus cosine squared x. Now I can replace that with sine squared x because that is what it equals. I'm also going to recopy down my sine x. And now I have sine x times sine squared x, which is a total of sine cubed x. And I've significantly simplified it there, so that's the end. That's all that I have to do. Example number 2. The sine of beta. Beta is just a different letter. Greek letter. There's nothing special about it. I'm just trying to expose you to more than one thing. So the sine beta times the tangent of beta plus the cosine of beta. In this case, I've got more things going on than just sine and cosine. Whenever you can, you want to get everything in terms of sine and cosine. We know from our green foldable from a long time ago that the relationship between tangent and sine and cosine is that tangent is sine over cosine. So I can replace tangent with sine over cosine. When I do that, I've got this fraction here. If I multiply that out, I've got sine of beta times sine of beta, which is sine squared beta over cosine of beta plus cosine of beta. Now I've got something that's a fraction and something that is not a fraction. I want to add them together. To be able to add two things together where one is a fraction and one isn't, I need a common denominator. So if I want this one to have a denominator of cosine of b, I've got to multiply by cosine of beta over cosine of beta. That's like multiplying by 1. I'm only doing it on this piece here so that I can get that common denominator. I'm going to recopy down this first part. And cosine times cosine is cosine squared over cosine of beta. When I do that, I have cosine squared plus sine squared on the top. And just the cosine of beta on the bottom. Sine squared plus cosine squared from our identities, back over here, sine squared plus cosine squared is 1. So now I've got 1 over the cosine of beta. And 1 over cosine is the same thing as the secant of beta. So that was a lot of steps, and people were kind of frustrated about that in class, how many steps that was just to get to this little bitty answer. But that's kind of the whole point of simplifying. This is definitely one of the more difficult problems that we're going to come across. And what made it difficult was this part ended up to be a fraction while the other part did not, and that made it hard to combine. The next several examples should be easier and very similar to what your homework is like. Example 3, cotangent of theta times the secant of theta. Cotangent, again, we want to get everything in terms of sine and cosine, so cotangent is cosine of theta over sine of theta, and the secant is 1 over the cosine of theta. I should be able to see from here that my cosines are going to cancel each other, and I have 1 over sine, which is the same as cosecant. So the answer is just cosecant of theta. Example number 4. Cotangent of x over cosecant of x. Cotangent, again in terms of sine and cosine, is cosine of x over sine of x. And then there's a big fraction here. Cosecant is 1 over sine of x. I know when I have a fraction over a fraction, I can rewrite the first one, take the second one and multiply by the reciprocal, or the flip. When I do that, my signs will cancel, and I have cosine of x over 1, or just cosine. And that one simplifies that way. Example number 5. The secant of alpha times the sine of alpha over the tangent of alpha. Again, not everything is in terms of sine and cosine, so I want to make it that way. Secant is 1 over cosine of alpha. Sine is sine of alpha over tangent, which is the sine of alpha over the cosine of alpha. When I have that, I've got a fraction over a fraction again, so I want to flip by the second one, multiply. So I've got sine of theta over 1 times, flip that second, cosine over sine. And when I do that, my sines cancel, my cosines cancel, even my 1's cancel, but we just know that 1 over 1 is 1. Be careful to cancel those out because I don't want you to think that's 0. When everything cancels, the answer is 1. 2 more examples to look at, and this brings in those second 2 groups of identities that I told you we'd look at today. Example 6 is that the cosine of pi over 2 minus x over the sine of pi over 2 minus x. This comes from the fact that the cosine and sine graphs are very similar, and if I cut pi over 2 off of either one, I could get the second. If I look at my cofunction identities, cosine of pi over 2 minus u is sine of u, so I can replace that. And I guess we should probably stick to x here. If I look at sine of pi over 2 minus u, I get cosine of u, or cosine of x. And I know that sine over cosine is tangent of x. So this thing that started out fairly complicated is now just the tangent of x. Our last example is the cotangent of negative u over the cosecant of negative u. On this one, I want to use my even or odd identities. If I look at the cotangent of u, or negative u, I get negative cotangent of u. If I look at cosecant, I get negative cosecant u. My negatives cancel. If I put that in terms of sine and cosine, cotangent is cosine of u over sine of u. And I know I've got a fraction over a fraction, so I'm going to go ahead and multiply by the reciprocal. The reciprocal of cosecant is 1 over sine. So if I flip that, that's sine over 1. And my sines cancel. My answer here is the cosine of u. Your assignment is A3, and that's page 379, numbers 15 to 25 all, and numbers 28 to 34 even. Good luck. Let me know if you have questions.